Hello everyone, welcome.
Hello
Hello
everyone. Good
everyone, good
morning. Good
morning, good
morning.
morning.
Welcome
Welcome
to
to
day
day
three,
three,
final
final
day,
day,
final
final
session of
session
our
of our
3 day
three-day
drafting
drafting
and
and
3D
3D
printing
printing
session.
session.
Um,
Um,
Today we're going to
Today
be
we're going to
talking
be
about
talking about
real
real
world
world
creation,
creation,
the
the
applications of
applications of
3D
3D
printing,
printing
as
as
well
well
as
as
the
the
economics that
economics that
surround
surround
3D
3D
printing.
printing. So
But
but
before we
before we
get
get
on
on
that, I
that, I
would
would
like
like
to do
to
a
do
little
a little
review of
review
what
of
we
what
have
we have
done so
done so
far
far for the past
for
for
the
the
last
last
two
2 days.
days. So we
So we
talked
talked
briefly
briefly
about
about
on the
on
first
the
day we
first day
talked
we talked
briefly about
briefly
what
about what
CAD
CAD
is
is
and
and
what it
what it
entails,
entails, the
the
basics and the
basics and the
foundation
of
of
CAD as
CAD
well
as
as
well as
3D
3D
printing.
printing.
We
We
also
also
talked
talked
about
about
Tinkercad,
Tinkercad,
which is
which
a
is a
basic
basic
beginner
beginner
software.
software.
It's
It's
good
good
to
to
learn.
learn.
It's a
It's a
software
software
that's
that's
good
good
for
for
learning the
learning the
basics of
basics of
3D
3D
printing.
printing.
Um,
Um,
we
we
also
also
talked about
talked about
what it
what it
means
means
to
to
accurately
accurately
design
design
various
various
components and
components and
assemble them
assemble them
together.
together.
Or during
Or
our
during our
day two
day two
session,
session,
we
we
focused
focused
on
on building and
building
building
different
different
parts and
parts and combining them together to form
one
one
single
single
object.
object.
I
I
explained
explained
what
what
it
it
means
means
to
to
fabricate
fabricate
each
each
piece
piece
in a
in a
factory
factory
and
and
assemble it on
assemble it on
site,
site,
which
which
saves
saves
time
time
for
for
construction and
construction and
also
also
cost
the
of
cost of
time
time
that it
that
takes
it
to
takes
make a
to make a
material. If
material.
you
If you
don't
don't
think of it
think
this
of it
way,
this way,
if you're
if
building
you're
something
building something
outside,
outside,
you're
you're
affected by
affected
a
by
lot
a
of
lot of
circumstances. For
circumstances. For
example, you're
example, you're
affected by
affected by
the
the
weather,
weather,
by the
by the
time, by
time, by
lights as
lights
well.
as
But
well. But
while you're
while you're
making
making
these
these
parts
parts
separately in the
separately in the
factory,
factory,
you are
you
not
are not
affected by
affected by
any
any
of
of
those
those
drawbacks.
drawbacks.
So that's
So
that's
that's
basically what
basically
we
what we
talked about
talked
on
about
our
on
day
our
two
day two
session.
session.
I would
I would
like to
like to
show you
show you
what I
what I
mean
mean
by
by
combining
combining
different
different
parts to
parts to
form a
form a
single
single
uh,
uh,
object or
object or
building.
building.
I was
I was
supposed to
supposed
show
to
you a
show you a
little
little
simulation
simulation
video
video
yesterday
yesterday
in our
in our
previous
previous
session,
session,
but I did
but I
not
did
have the
not have
chance.
the
So I
chance.
would
So I
like to
would like to
show that
show
to
that
you.
to you.
This will
This will explain
um,
um,
this
this
explains
explains
the coming
the coming
together of
together of
different
different
parts,
parts,
snap
snap
fits
fits
without using
without using
screws
screws
or
or
adhesive
adhesive to make
stick
parts stick
together.
together.
So I'll
So I'll
proceed to
proceed to
showing you
showing you
this
this
now.
now.
So if you
So if you
observe the
observe the
video, you
video,
can
you can
see
see
different
different
parts
parts
coming
coming
together.
together.
Each one
Each
is
one is
made
made
separately.
separately.
I'll display
I'll
it
display it
again,
again,
and
and
then
then
assembled
assembled
together,
together,
fitting
fitting
accurately
accurately
where it's
where it's
supposed to
supposed to
be.
be.
Doing this
Doing this saves
a lot
saves a
of
lot of
time
time
in
in
construction as
construction
well.
as well.
Also, when
Also,
you
when you
check the
check the
simulation
simulation in our 3D environment, you can
basically
basically
confirm
confirm
any
any
mistake
mistake
that you
that
might
you
have
might have
made.
made.
So
So
that's why it's
that's why
very
it is very
important,
important, like I said
in our
in
day
our
two
day two
session, why
session,
it's
why it
very
is very
important
important
to
to
ensure that
ensure
all
that
of your
all of your
measurements
measurements
are
are
accurate.
accurate.
I had a
I had a
question
question
in our
in our
previous
previous
session
session
asking how
asking
do
we
we ensure that
ensure that
our
our
points does
prints
not
does not
fail,
fail,
and that's
and
one
that's
of the
one of the
important
important
things to
things
take
to
note.
take note.
You must
You
always
must always
ensure that
ensure that
the
the
dimensions are
dimensions are
correct,
correct,
and you
and you
check the
check the
parts
parts
in the
in the
3D
3D
environment
environment
to
to
ensure that
ensure that
there's no
there's no
mistakes
mistakes
before you
before you
make the
make the
actual
actual
product,
product
and you
and
don't
you don't
waste
waste
money.
money.
So
So
now that
now
we've
that we've
gotten that out
gotten
of
that
the
out of
way,
the way,
for our
for
day
our
three
day three
session,
session,
by the end of today, you will understand how
by the end of today, you will understand how 3D designs become physical object through 3D printing, how real-world problems are solved using this process, and how these skills can be turned into useful products or ideas. So today is not about designing anymore. Today is about making your design real and understanding what happens after the design. Yesterday, after we built a full design of our house with separated pieces, and after turning that into something real, I would like to simply explain. Today's goal. As I said, we are going to understand the physical relation between 3D modeling and the economics part of it. So understanding what comes after you've made the physical object is the goal of today. So the fabrication pipeline, what it simply means is the process, what the everything has to go through some form of some form of process. You don't just go from step one all the way to step five. So you must follow each step sequentially and ensure that you do not miss anyone. So the first one is an idea. So every product starts as a sketch to solve a real problem, and that's basically it. Every product starts as a sketch because it's basically an idea and something that you think of. So it's if you think of it as the beginning of something, you basically get this vision of creating something new, and that's what it means. So every product starts as a sketch to solve a real problem. And after you've figured out the problem, figured out how you want to solve the problem, then we go into our CAD design. This is the digital 3D modeling where we define exact dimensions. Like I said, it is imperative. It is something that you cannot look over. You must ensure that all of your dimensions are done correctly, especially when you're doing this not just as a hobby, but as a job. Especially if you're doing it as a job, you cannot risk the life of people because of structural failure, just because you were too lazy to make some adjustment, or because you were too tired to check or confirm your dimensions. You have to recheck, confirm at least 4 times before sending any product down into the production line. When I mean production line, it simply means that your idea has gone from design phase into production. And by the time an idea has moved from design to production, it's basically too late to change anything concerning that specific product that has already been made. The product has already been made, the mistake has already been done, and the loss has already been recorded. So there's nothing you can do but go back to drawing board and correct your design again and try again. So in order to avoid such mistakes and such losses, you have to ensure that you define the exact dimensions. Sorry. I would like to confirm.
Okay,
so when we move from CAD design to when we're done with a CAD design, the next step is slicing. That is converting the model into layers for the printer. So we basically talked about this on day one and day two, and we said that slicing is when the printer reads the part Imagine slicing. It literally means cutting or slicing. It's not even a fancy word. It literally means what it says, to slice apart into thin layers. Layers so thin that I don't think you'll be able to see it with the human eye unless you're using a 3D modeling, because it's like a point zero zero something mm, and that's how tiny each layer is. So imagine stacking like 200 of such layers, and that's how you get the full part, and that's what it means to slice. If I go into uh, Bamboo Studios and show you what I mean, you should be able to get a better understanding. When I say slicing, so we have this foam stand right here, and I want to check the layers. The reason why these were added is called supports. As you can see, this region of the piece is floating in mid-air. It's floating in the air. So because there's nothing underneath, like I said, each layer starts from the bottom and goes to the top. So it needs to make structural support all the way to the top and begin the print right here. This easily breaks off. You can see the way it is printed right here. It's printed in such a way that it can snap off as soon as you're done printing. So it's very it takes into account all of those problems and solves it for you. So when I say layer by layer, this is what I mean. So observe quickly. So when I take this down, you can see I'm gonna take this all the way down. So our print is gonna start like this. It's gonna start like a little fine sheet of paper on the machine, just something like this. So this is what it means by slicing. So it's going to combine layers like this. About, if we can check how many layers it is, it says it's 694 layers. So that's, we're stacking this 640 45 times. That's what it basically means before we can get this print. And for each layer, the 3D printer is going to move all around. Observe. So now this is the first layer. It's going to move all around and trace each part and trace each one. So this is basically how it starts. So this is layer one done. All of this is just the first layer. And that's done. The first layer is done. And then it moves up to the second layer. Okay, we're in layer 6 now. And then it does the same thing. It goes all the way around, does the same thing. And then you move slowly up from the bottom to the top. So you can see, this is what I mean by the support. So because this region of the part is floating in mid-air, it needs to make a support so that it can create this. Because you cannot just start printing from mid-air, because at least we have the laws of gravity. There's no way your printer is going to start printing from the middle of the machine. That's like printing from here. That's something impossible to do. That's why we have to start by making supports for any floating region, and then you go all the way up, and then you have the complete file. So that's what I mean when I say layers. When we're talking about slicing, that's basically what it means. Converting the model into layers for the printer. So slicing literally means slicing, cutting the part into small pieces. And then we go into real use. This is the final physical object solving the real world problem. In order to create this, you must have thought of a problem that you want to solve. That's why you made this.
So
from digital to physical, like we said, the house we modeled or that we modeled yesterday only existed digitally. To bring it to the real world, we must treat it as engineering assembly, meaning that we must treat it as an engineering part. Like I said, you print each part, and then you assemble it together. That's what we mean by engineering assembling. So exporting the model. So the 3D printer only reads a certain file. So if you remember softwares like Microsoft Word, when you save a document, it has an attachment, an extension at the end that says .doc, that's .doc. Or if you're saving a PDF, it says .pdf. So it's basically the same thing. For the STL file, it's going to stay .stl. It's a kind of a 3D model file that the 3D print that it's the only file that the 3D printer can read. Which means that this file that you're seeing in the Bamboo Studios already is already an STL file. So I had to convert it into an STL file before it was sent here. And in day one and day two, I believe I showed you how to convert your model from a drawing file into an STL file that the 3D printer can read and understand. Like I said, it's a machine and it has a particular language that it can read, just like each and every one of us has a language that we can read. So you cannot feed it a wrong file and expect it to work. So you have to take note of that. There's a specific kind of file that you have to use when you want to export the model. So to print designs, it must first be exported as STL file. This file contains the triangular mesh information needed by the slicer. When we say mesh information, it's basically, if we go back to Bamboo Studios, this is basically the mesh information. All of this design, all of this is what we call the mesh information. It turns it into an actual data source that the 3D printer can read and understand. Think of it as a different kind of language.
So you think of it as a different kind of language, and that it should be easier for you to understand that way if you think of it as another kind of language that the printer can understand. So we will proceed with hold on. I really want to make sure you guys understand this. So it acts as a universal printer instructions. When I say universal printer instruction, it means it's going to be the same for my printer. It's going to be the same for any printer you're using. It's going to be the same for any printer at all. All printers use the same STL file. So that's what I mean by it's a universal printer instruction. Simplifies geometry into flat surfaces. That should be self-explanatory. So it simplifies all geometries and makes the printer reads it as a flat surface, which makes it easier for the printer to print this. So it's an essential bridge between the CAD and the print. I cannot stress how important it is. Very, very important. Slicing software. So converting to G-code. The printer does not understand the whole object at once. It only understands layers. Slicing software like Pure Slicer converts 3D model into hundreds of printable parts, telling the nozzle exactly where to move. So I know you're always wondering, how does the printer know where to go? So now this should explain it to you. So the slicing software converts the 3D model into hundreds of printable parts. I didn't say parts like pathways. which means direction, which means telling you where to go. So it converts the model into like a sort of a think of it like a sort of roadway guiding the 3D printer's hand, telling it where and how to move. And that's what we mean by the nozzle, because it's the nozzle that if you check back on day one, I explained what the nozzle is. It is the heated part of the 3D printer where where the the plastic, the heated melted plastic comes out from to form your part. So the nozzle right there towards the end, that's what I mean. So when we talk about engineering print settings, so there are various settings when you're using your 3D printer. So talking about the print speed, so you can always adjust how fast you want your printer to go. But you should take note, the faster your print is, the the less likely that it's going to be perfect. So what I mean is, the faster you go, the rougher your print might be, depending on if you have a high-end modern printer. What I'm currently using is the A1 Bamboo Labs Studio. Now it's one of the most modern recent ones. So faster prints, like I said, faster prints save time, but may reduce surface quality and strength. Like I said, do you want it fast or do you want it done right? You can't have both. Well, sometimes you can, but it's unlikely that you'll have it every time. That's what I mean by depending on how fast your print is going. If it's a complex shaped object, if it's a complex part shaped in a in a weird way, or it has a very unique geometry or a unique shape, you would not I would not advise you to print it at 100% or very very fast, because if you run your printer at that fast, you're going to have a lot of print failures and mistakes, and you're going to be wasting a lot of materials. Now next we talk about infill density. When we talk about infill density, I'll have to show you the Bamboo Studios for this again. If we go into Bamboo Studios, infill densities, when we say that, it means, we can actually create this part and make the inside hollow. What I mean that we make it hollow, it means there's going to be nothing inside. All we'll be making is just the frame, the structural frame of this. There's all of these extra infills. That's what we call infill. It means how sturdy or how strong the part is going to be. Because think about it this way, if we make only the frame of this part, it is easily going to break because there's going to be no strength, there's going to be no support holding it. So when we talk about infill, this is what we're talking about. How strong the part is going to be, how much of it is going to fill inside it, and how much of it is. So the infill also determines the weight of the part and how much of your material that you're using. So the less infill that you use, you're going to save more money on material, but your products are not going to be strong. And I doubt anybody who is a businessman wants to make a faulty product intentionally. So there's no really my advice would be to pay attention to the infill, because it's better to make a strong material than make a fragile one, because you're trying to save cost of material. I would not advise anyone to do that. As someone in engineering myself, there is no cutting corners when dealing with engineering. So you should, if you plan on having a career in CAD, I'll advise that you should start learning the habit of being as thorough and as precise as you can. I mean, be so thorough that it makes you sick. yourself that you cannot, that you're always forgetting something. That's what I mean. You have to always be thorough, because if the mistake has been made and this product has been shipped, for example, you're selling this, if the mistake has been made and you ship this product and people leave bad reviews because your products break easily, that's not something that you can easily fix by saying, oh, let me make another one for you. I don't know if you understand me. So that's why it's very important that you do not cut any corners when dealing with such engineering problems. So that is basically what infill is all about. And then material use. Optimization is key. More material increases cost and total print time. So like we said about infill density, the more material you use, the more cost you're going to incur, the more print time that you're going to have. So you have to find a balance for everything. And the more you do it, the more you do it, you get more used to it. What I mean is, it's a process. It's not something that you can easily figure out or learn at a go your first time. So the more you make such products, the more you can find the sweet spot, or like the best optimized zone for your material and print time. So it saves you a lot of money as well as material. So the real printing process. So when I talk about the real printing process, the printer builds the object one layer at a time. We've already established that, and every movement must be accurate, because when the printer reads the STL file, it converts it into paths, like we said, pathways that the printer is going to move. If the design or settings are wrong, the prints can fail. More often than not, the prints will fail if the design is wrong. Now, common print failures, why accuracy matters is small mistakes in design or print settings can cause catastrophic failures. And something like this is, like I said, you don't. It's better you ensure that everything is done properly than trying to fix a mistake that you have made, because making a mistake in such production can have serious consequences, especially when you're working in a company that deals with millions of dollars, and you're making a part that's wrong, and you're making 500 of these parts, and each of these parts cost about $50. Now, if you've made a mistake in these parts and you've made 500 of them, that's 500 parts scrapped, and that's a lot of money wasted. It's not something that you can easily fix by going back to the CAD design and saying, oh, I want to fix this. So that's why you must ensure that on the first time that it is correct. Now, so our real world applications for 3D printing. So machine parts, replacement gears and brackets. So you can make custom tools for different machine parts, as well as a prototype for rapid testing of electronics, as well as architecture. So making accurate city plans is what I mean by architecture. If I should be able to show you what I mean by making accurate city plans. If I go into Bamboo Studios, I want to explain to you what I mean by this. So this is what I mean. When we say architecture or city planning, you can see when we talk about city planning, most of the buildings we see in modern society are pre-planned. Most of the structures are pre-planned. So in order to ensure optimal space, you can see each and every one of these houses have been sketched and detailed perfectly. So this is how modern day engineers accurately determine the dimensions of various buildings. This is how they determine where each building should go and how they determine how much space is required. This is what we mean by city planning. So they ensure that each building is scaled down. So like I said, when we talked about yesterday, if I wanted to get the accurate dimension for this particular building, all I will need to do is multiply this by either 50 or the scale that's used, and I'll get the accurate dimension. So that's how we can use this as a prototype to know how we want to plan our city. For assuming you're making a, if you're ever given a contract job to make a town or to construct houses for a certain district, this is how it's done. This is how you figure out each and every one. So we have our stadiums, we have business centers as well. It's it's very, at this point it might look complicated, but think if you think of each one as a separate piece that comes together to form all of these, it's not that complicated, because they'll have to start by making each one like this should be. That's why if you look at Canada, most of the houses are similar. It's because of this. I can just copy this building and copy this here. So that's how most of these structures are made. So that's what I mean by architecture. So understanding product value. So we're going to go into mainly the economics of this. I really want to explain how profits, losses are made in this session. That's what we'll be doing. Okay, so how products make profit. So today we'll talk about today, not when we talk about 3D printing, it's not only about making cool objects, but most people think that 3D printing is just simply making a cool object, but businesses don't survive on making cool objects. If you plan on turning this into a business, it's not just about making it into a hobby or making objects that look nice. So businesses strive by creating value. And when I say creating value, you have to think of a problem. Look for a problem near you and think of a solution, and that's how you create value. So it's not, for example, if you look at this headphone stand, it's not just a piece of plastic. But why would anybody want to buy a headphone stand? It's because it solves a problem. It keeps headphones organized, and that's the problem that it solves. It reduces desk clutter. So it protects expensive headphones from accidental damage. So that means that people are not paying for the plastic. They are paying for the problem that you've solved. They're paying for the convenience, and they're paying for the solution. That's what we mean by creating value in the product. So if you solve a real world problem, people are willing to pay for your solution. So that's what I mean by think of a problem close to you, and that's how you can create value in a product. So now, if we look at I just want to give a quick example so you can understand the economics of this. Now, this is for a headphone stand. All of this is just, I've done most of the calculations, so just please follow me. So now, if we each gram of filament, if I go into the 3D printer cam and show you what I mean is 1,000 gram of filament. That's this 1,000 gram of filament is about $25. So that's about 1 kg is about $25, and that's what I mean. So in order to get to determine the cost for each gram, all you have to do is divide 25 by 1,000, and you get 0.025 gram per dollars. So this is how much it's going to cost per each gram. So if you're using 120 gram of material, it's going to cost you 120 times 0.025, which is $3. So the total cost of material that you're going to be using for the headphone stand, if it is 120 grams, is going to be about $3. So the material cost is exactly $3. Something that you should notice: the printer doesn't care if the object looks expensive or it looks beautiful. It only cares how much material is used, and the printer accurately gives you the calculation for this. Tells you how much material that you're going to use. So the more plastic that you use, the more money that you're going to spend. So who thinks a larger product automatically means more profit? A larger product doesn't necessarily mean more profit. A larger product usually uses more material, which increases cost. So just because a material is bigger or a part is bigger does not mean it's going to be more expensive. So every gram of plastic costs about 2.5 cents. So precision in your slicer saves money. That's what I mean by you have to ensure that when you're using your slicing software, because if I go into Bamboo Labs, when I was talking about slicing, if you go into your slicing software, you must ensure that it's all accurate, and that's what I mean. So when you're in this stage, it tells you, it gives you majority of the information, because a lot of this is a lot of information. That's why it's taken quite some time. So yeah, so it displays most of the information here. Tells you how much gram. So I'm going to be using a total of 118 grams for all of these. I know you would expect me to use more, but because I reduced the scale of these buildings, that's why it's going to be less. So that's what I mean by so that's what we mean by every gram of plastic. Every gram of plastic costs you 2.5 cents, and you must ensure precision in your slicer so that you can save money. It's very, very important. And then we go into energy and time costs. Now this is very important. I really want you to take note of this, because when your printer is on, you are not only paying for your material, you're also paying for energy. That's You're paying for electricity. You're paying for the total amount of time it takes your prints to finish. So material is not only the expense, because the printer also consumes electricity. So let's say a print takes approximately 6 hours. Let's just say it takes 6 hours to make about 3 or 4 of these parts. So for example, the electricity cost is estimated at about point $50. That's about 50 cents, and a print time of 6 hours. During those 6 hours, the printer uses power. So material cost is $3, and electricity cost is going to be about $0.5. So already our total production cost is already sitting at $3.5 already. That's what it costs. That's what it's costing us already to make these products. Now, calculating the profits. Now, this is where we talk about the selling price. In business, the cost of producing your material is how you determine how much you're going to sell your product. So the difference between your selling price and your production cost is your profit. This is what pays for your time and business growth. So example, we put the selling price for the headphone stand at $15. If we minus 15 from 3.5, we have a net profit of 11.15, even after paying for material and electricity. This money can be used to buy more filament, upgrade the printer, purchase tools, or grow the business. If you let's pretend that you're 16 years old, you own a single 3D printer in your bedroom. You sell one headphone stand and you earn $11.50 profit. That's a very good, that's nice, and that's a very good business model. If we scale this production and we produce about 10, that's production costs is going to be, let's say, assuming we're making 10 of these headphone stands. Remember, we're selling it for I believe we're selling for $15, and the production cost was about 3.5. So it's going to cost us $35 to make 10 of these. If we're selling it for $15, 15 times 10 is going to give us $150 for this, and our final total profit is going to be 150 minus 35, which is going to be 115. Now, the good thing about 3D printers is that your products, they are non-perishable items. They don't have an expiry date, so you can list them online and wait for buyers. There's never going to be a time where your plastic melts because you left it out in the open for so long. It's never going to happen. So that's one of the good things about 3D printing. It's so, and another thing is that with 25 dollars worth of material, I could literally print about 50 different headsets with $25 worth of PLA material. So that's what I mean when I talk about scaling production. Think of it as there's no way none of these products are going to expire. So it's going to be there and waiting for you to sell. All you have to do is identify a problem close to you and think of a way to solve it. And there's no way you're not going to get value for the product that you have made. Understanding financial loss. This is very important. So failed prints consume resources without creating value. This is a direct loss to your business. 80-gram filament wasted is $2 in filaments. Time wasted, 4 hours of energy. That's about a $0.35, and that's about $2.35 per failure. And if you failed about 10 times, that's almost about close to about $12 or $15 in failure, in loss. And if you keep making such mistakes, you will keep losing money. That's why you have to ensure that your print does not fail. And how do you ensure that your print does not fail? You ensure print does not fail by making sure that all dimensions are accurate and correct. Very important. Now, the business advantage of 3D printing, like I said, low storage risks. So PLA plastic does not expire. Your inventory stays good for a long time without degrading. What I mean is that no matter what you make, it's not going to spoil. It's not going to expire. So that's what it means. So your inventory stays good for a long time without degrading, as long as you store it properly. So there's very low storage risk. All you have to do is just find a very nice spot for all your 3D prints, a display case or something. Also, a print on demand only prints when an order is placed. This reduces waste and saves your initial cash. If you're working for someone, if you're selling your services, it's best you print on demand. You print when someone demands a specific part. Custom tools. Create personalized name tags or holders that big stores simply cannot sell, which means that you can sell an ad online saying that you can create a personal item, personalized stands, personalized holders for people with their names or with their logos or with their own company logos. And that's another form of value, because you can hardly see personalized items in high class in big stores. they don't hardly sell such things. So I want to quickly explain some of the things that I do plan to print that I want to distribute to schools and community centers. So some of these things include quickly. Some of these things will help in 3D engineering, as well as mathematical equations, as well as precision measuring tools. Because even up to this day, I still use a lot of my physical measuring tools. Most of the time, I still do have to make a lot of my drawings by hand. Not often, but at least sometimes I do have to make some of my drawings by hand. So you have things like a foldable modular ruler set. So I plan on making this and distributing to community centers for kids, as well as STEM project schools. Also making a handy dimension set, as well as a high precision ruler set. Each and every one of these is going to be customizable. Most of these tools are high precision tools for measuring angles and complex geometries. But I believe the STEM colleges right now are in the stage where most of the kids already understand the use of these tools. So quickly for our final close, I want you to remember this: the real value of your product is not the plastic. Whenever you're making something, the real value is not in the plastic itself. The real value is in the idea. Anyone can buy a filament. Anyone can buy a filament, and anyone can buy a printer. But not everyone can identify a problem and create a solution. If you understand what I mean, this is what designers, this is what engineers, inventors, and entrepreneurs do. So it's not just about getting a printer and making objects that look cool. It's about creating products that actually have value, and that's exactly what a 3D printing allows you to do. It is a it's a very, very important part of the modern industry. And over the last 3 sessions, we have understood the various parts of a printer, how it works. So it's not just about getting a printer and starting to print different items. You must understand the basics of CAD. You must understand the basics of a of a 3D modeling. I told you about two softwares that you can use. One is a Tinkercad, and another is a Inventor, which is a more advanced software. And for your slicing, you can always use the bamboo use the Bamboo Studios if you need the slicing software. So we also learned on the second day what it means to design a house using various parts. If I go back and show you our video, you can see what I'm talking about right here. On day 2, we understood what it means to build separate parts and have each of these separate parts come together as one single item. So that's what we talked about in day 2, modular design. Like I said, most construction done in the modern time, it's done this way. Each of these parts are built separately in a factory, and then they're transported on site and then installed. So that's what we focused on our day 2. And then day 3, we talked about basically the economics of 3D printing, understanding how to make profits, as well as I would like to express My appreciation to Black Kids in Action (BKIA), as well as Canada Service Corps for sponsoring and supporting this 3-day fabrication studio program. Your investment in education, innovation, and youth development has given not only me, but the participants the opportunity to learn valuable skills in 3D designing and engineering thinking, as well as digital fabrication and entrepreneurship. So, over these 3 days, we have explored how ideas can be transformed into real world products and how technology can be used to solve practical problems. So, on behalf of all the participants, thank you for making this learning experience possible. Your support is helping to inspire the next generation of creators, designers, engineers, and innovators. Thank you for believing in the power of education and for helping us build a brighter future with technology. And with that, I would like to appreciate everyone for taking the time to be here. And please do remember, if you want to rewatch any of these, it's saved on YouTube, and the YouTube channel name is Fab Studio 3D. So it's just Fab Studio 3D, and you should be able to rewatch most of it, because in day one we talked about the basics, and I introduced a basic software that anyone can use to 3D model. In day two, we used a more advanced mechanical drafting software, Inventor, which is used for day-to-day production of buildings, construction, and fabrication. In day three, we talked about economics, combining the 3D printing with economics to see how you can make profits as well. So all of these videos you can find on YouTube. It's all saved. And any questions you have, please forward it there. So thank you very much for making the time, and do have a wonderful day. Stop streaming. Further your business. So as we come to the